Aufbau principle. Aufbau comes from the German word aufbauen, which means to build. In essence, when writing electron configurations, we are building up electron orbitals as we proceed from atom to atom. As we write the electron configuration for an atom, we will fill the orbitals in order of increasing atomic number. The electrons gather around the nucleus in quantum orbitals following four basic rules called the Aufbau principle. No two electrons in the atom will share the same four quantum numbers n, l, m, and s. Electrons will first occupy orbitals of the lowest energy level. Electrons will fill an orbital with the same spin number until the orbital is filled before it will begin to fill of the opposite spin number. Electrons will fill orbitals by the sum of the quantum numbers n and l. Orbitals with equal values of n plus l will fill with the lower n values first. The second and fourth rules are basically the same. The graphic shows the relative energy levels of the different orbitals. An example of Rule 4 would be the 2p and 3s orbitals. A 2p orbital is n is equal to 2 and l is equal to 2, and a 3s orbital is n is equal to 3 and l is equal to 1. N plus l is equal to 4 in both cases, but the 2p orbital has the lower energy or lower n value and will get filled before the 3s shell. Probably the worst way to use the Aufbau principle to figure the fill order of an atom's orbitals is to try and memorize the order by brute force. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p. Fortunately, there is a much simpler method to get this order. First, write a column of s orbitals from 1 to 8. Second, write a second column for the p orbitals starting at n is equal to 2. 1p is not an orbital combination allowed by quantum mechanics. Third, write a column for the d orbitals starting at n is equal to 3. Fourth, write a final column for 4f and 5f. There are no elements that will need a 6f or 7f shell to fill. Finally, read the chart by running the diagonals starting from 1s. The graphic shows this table and the arrows follow the path to follow. Now that the order of orbitals are known to fill, all that remains is memorizing how large each orbital is. S orbitals have one possible value of m to hold 2 electrons. P orbitals have 3 possible value of m to hold 6 electrons. D orbitals have 5 possible values of m to hold 10 electrons. F orbitals have 7 possible values of m to hold 14 electrons. This is all that is needed to determine the electron configuration of a stable atom of an element.